Here are some reminders to help you get the most out of your DIVE CD lessons. First, work the problems with me. Work every single problem that I work and take notes on everything that I write on the board. One thing I encourage you to do is on the first practice problem, work that one with me, but then for the second and subsequent ones, pause the CD, try to work the problem on your own, then fast forward to the answer. If you got it right, great, you can move on to the next one. If you got it wrong, rewind the CD, look at how to solve the problem, and figure out how to do it correctly. Next, anytime you need to, pause and rewind the CD until you understand that particular concept. The ability to pause and rewind so easily is what makes DIVE CD lessons so much better than a live classroom lecture, so make sure and take advantage of that technology. Next, remember the purpose of math is to teach you to think and to solve problems, to effectively and efficiently think and solve problems. In the lower math levels, there's lots of mental math. In the upper levels especially, this is the most important purpose of math, is to teach you to think and to solve problems. Next, do all of the problems in the problem sets. It depends on the course that you're doing, but typically you'll do 3 to 5 problem sets a week, so that means 3 to 5 CD lessons plus a test. Next, work the homework problems and your test problems too. Work those vertically. Split your paper in two and work them vertically. And of course, make sure you show your work on your problems too. As you work them vertically, write each step down and write each subsequent step underneath the previous one. And this will help you sometimes to recognize patterns a little bit easier and help you solve the problem better. Also, use a calculator sparingly, only for geometry problems and some word problems. Don't use it for Math 7-6 or below that for any of that. Algebra half and up, use it sparingly. And lastly, have a good attitude. Every day you do school, you have a choice to make. It is your personal choice to have a good attitude, work hard, do your best, or to be lazy, complain, whine, and have a bad attitude. So choose right now to have a good attitude. Dive in, take advantage of this CD lesson, and do your best to learn the math that you're going to learn today. In Lesson 1, we'll be reviewing the addition and subtraction of fractions and then also studying lines and segments, and that should be a review for you as well. Well, to review addition and subtraction of fractions, that's part A of this lesson, why don't we just go ahead and do some problems. Look at practice problem A. I want you to add those two fractions together. And hopefully you remember that in order to add fractions, you have to have a common denominator. So remember the denominator, that's the number on the bottom of the fraction. So that's the 8s that I'm circling. Those are the denominators. They're common, they're the same, and so that means we can add the two fractions. And all we do is just rewrite this. We can put this denominator 8 over there again, and we add the two numerators. 3 plus 1 is 4. Now, one other thing we do on fractions is we always want to write them in their most simplified or reduced form. And we look for a common factor between the numerator and denominator. And we recognize that they both have a 4 in common. So we could factor that out. And so we would say 1 over 2 is the solution there, because we can factor a 4 out of that. 4 times 1 over 4 times 2. The 4's factor or cancel out. Let's try another addition problem, 1/3 plus 2/5. Now this time we don't have common denominators. And if you remember, you have to have common denominators, so what you do is you find the least common multiple between the denominators. And so you think, well, 3 times 5 equals 15, and so does 5 times 3, that equals 15. So that would be the least common multiple. Now they would both have 30 as a multiple in common as well. 3 times 10 is 30, and 5 times 6 is 30. But that's not the least or lowest common multiple. That's why we use 15. So we multiply above and below that 1/3, we multiply above and below by 5. The 2/5 multiply above and below by 3. And so now what we do is we have two fractions. They're the same fraction. When we multiply above and below by the same number, we don't change that number. We just change the way it looks. And so we can just rewrite this 5 over 15 plus 6 over 15. That equals 11 over 15. So that's the result of adding those two fractions together. Hopefully you remember how to do this, and this is not something that just seems totally new to you. I know you've seen this before, but maybe it's been a long summer. It's hard to remember everything that you learn in school. So if you have forgotten how to do this, just be patient with yourself. Review the lesson. That's why you're using the CD. One of the reasons is so that you can rewind and you can go at your own pace. And if you get stuck on something, just rewind and try to understand it. And we'll also do quite a few practice problems, and that will help you reinforce the concepts and just get used to doing the steps again. So look at practice problem C. Let's add those three together. Now we have a 1/4 minus 1/5 plus 2/3. We know we have to get a common denominator in order to work this problem, so let's work on that for right now. Get a common denominator. And the best way to do this is just look at your denominators and multiply them together. 4 times 5 times 3. That would equal 60. That is a multiple that all of them have in common. 60 is the lowest common multiple. And so we need to multiply all of them by a factor so that we get 60 in the denominator. And so the first one there will multiply above and below by 15. The second one above and below by 12. The third one above and below by 20. And so let's rewrite this. 15 over 60 minus 12 over 60 plus 40 over 60. Now what we want to do is let's just go ahead and work in pairs. The first and the second term there, that's a subtraction, so we'll do 15 minus 12 is 3 over 60. Add to that the 40 over 60, and we end up with 43 over 60. And so let's just think about that. Can we reduce 43 over 60 anymore? Well, 43, that's a prime number. That's one of those numbers that is only divisible by itself and 1. And so we can't simplify this anymore. And I like to put a box around my answer. That just differentiates it from the rest of the problem. It helps you find out where the answer is. If you always put a box around your answer, then when you're doing your homework or if somebody's grading your work, they can find your answer quickly. Let's do one more problem. This one has a mixed number subtracted from another mixed number. And a mixed number, that's where you have a whole number part and a fraction part. And what you want to do on these is work on the whole number part separate from the fraction part. So like on this one, we would do 3 minus 1, and then we would do 1/5 minus 7/10. Well, first though, we know that when we subtract those two fractions, we have to have common denominators. So let's go ahead and do that first, and let's just write this 3 and 2/10 minus 1 and 7/10. Now let's go ahead and work on the fractions first. 2/10 minus 7/10. Well, we cannot subtract 7/10 from 2/10. That's a larger number than 2/10. So what we have to do in that 3 and 2/10 is borrow from the 3. And we have to borrow 10/10. And so we borrow and we change that to a 2. And we add 10/10, and that would make this 12/10. Because 10/10 plus 2/10 is 12/10. Now let's work on our fractions. 12/10 minus 7/10 would be 5/10. And now let's subtract our whole number parts. 2 minus 1 is just 1. 1 and 5/10. Well, 5/10 can reduce to a half, so we can just write this 1 and 1/2. So you basically have two subtraction problems when you're working with mixed numbers like this. You subtract the whole number parts, and then you also subtract the fraction parts. Same with addition. If this was addition of a pair of mixed numbers, you would add the whole number parts and add the fraction parts separately. Part B of this lesson is on lines and segments. And let's just review what the definition of a mathematical line is. Now, actually a mathematical line, we cannot even see it because it has no ends on it, and it has no width. It just kind of goes on forever and ever in both directions. What we do to represent a mathematical line is we draw a line on our paper and we put arrows on the end of it, and that represents a mathematical line for us. Now we can give a name to a line. We can put a couple of points. You have to have at least 2 points to define a line. And so this one, we could call it line AB, and we'll write capital A, capital B, and then we put a small line over the top of it, and that, what we would say, is line AB when we see that symbol. Now we could also write it line BA. The order of the letters does not matter. And we could also add another dot if we wanted to as well, and call it line AXB. It has to have at least 2 points, though, labeled to define it as a line. I mean, just think about it. If I put a dot right here, there are an infinite number of lines that I could draw through that dot. If I have 2 dots, there's only 1 line that can pass through both of those. So that's how we define a line, is by 2 points at least. Now, a line segment, we draw that by putting a line, and then we put dots on the end to represent that it's a segment or part of a line. For example, in the line that we have there above, if we just looked at the distance from A to 6, that would be a line segment. I'm sorry, from A to X. We could call that AX, line segment AX. And we would give it this description, AX with just a bar over it, no arrows on the ends, because it's a line segment, not a line. And just like a line, it doesn't matter the order of the letters. We could call it line segment AX, or we could say XA with a bar over it. Either way, that defines that line segment. Now look at practice problem E. I have a line segment drawn there, line segment ABC, and I show that the distance from A to B is 6.5 units. Now we didn't give it any length units like inches or feet or miles or anything like that, so we'll just say it's 6.5 units from A to B. And then I also gave the distance from A to C of 19 1/8 units. Now what I want you to do is figure out the distance from B to C. So you could do that because you know the total distance from A to C. You could subtract out the distance from A to B, and you could figure out from here to here, basically. That would be BC. So we're going to have to do a subtraction problem in order to figure this out. And so we will say 19 1/8 minus 6.5. Okay? So the first thing we want to do is get our denominators the same. And so that would be 19 1/8 minus 6 4/8. So now we have common denominators, but we cannot subtract 4 from 1, and so we need to borrow from that 19. And so we'll change the 19 to an 18, and we'll add 8/8 to 1/8, and that'll change this to a 9/8. So now we have 9/8 minus 4/8. That would be 5/8. So I'll just write that over here. And then the whole number part will be 18 minus 6 is 12. 12 5/8. That's the distance from B to C. And we're not concerned about units of length of any kind, so we'll just leave it like that. 12 5/8. Let's do one more problem dealing with line segments. In this one, you've been given a length from X to Y and a length from X to Z. I want you to find the segment XZ, what its length is. That would be the entire thing, right, from X to Z. So all we have to do is add those two given lengths together. So we'll say 7 1/4 plus 9 1/8. And so we have mixed numbers. Let's go ahead and add the fraction parts first. And we need to have common denominators, so 1/4 needs to be 2/8 plus 1/8 would be 3/8. I'll write that down. And then add the whole number part. 7 and 9 is 16. So we're not concerned with any length units like meters or feet or miles right now, so we just write down the number 16 3/8. So make sure you know the difference between a line and a line segment and how to write one, the symbols anyway, how you would write the symbols to designate a line or a line segment. And then make sure and do all of this problem set that they have, because it has lots of good practice on adding and subtracting fractions. Okay, well that's all for lesson 1.